we created SkyWater, we were very focused on how can we have a CapEx-light model. The idea of us was taking a fab that knew how to run volume manufacturing and build in a R&D capability. The idea of SkyWater was really to create what we call a technology foundry. So a foundry that didn't just make volume products, but also had the ability to innovate with our customers. We're replacing all these legacy technologies with all these new technologies. Our customers are just bringing new products to market. And we've got a bunch of new investment going in the fab that gives it another 30 years of life. You imagine being in space, you've got to fabricate an IC because you need to solve a problem. These are all things that are going to create a whole host of new opportunities.
Hey, Tom, thanks so much for joining us
Absolutely.
here on Microjourneys. Great seeing you, man.
Yeah, absolutely. Good to see you as well.
It's been a long time and right on the heels of a pretty awesome announcement. So, hey, first off, congratulations.
Thank you very much.
Why don't you tell the audience a little bit about what just happened?
Yeah, so SkyWater has closed the acquisition of Infineon's Fab 25 in Austin, Texas. This brings new foundry capacity, 200 millimeter foundry capacity to the domestic semiconductor market. We think the timing, not only of having this new capacity, but the types of capabilities that we're going to now be able to offer domestically, not only is synergistic with what we're already doing at SkyWater, but plays well into the Made in America, the whole desire to just be able to have more domestic sourcing for foundational semiconductors.
Now, are you envisioning this as an expansion of current capabilities, a new enhancement to, help complement what you're doing? How is this going to fit into the ecosystem?
Yeah, it's an interesting dynamic because the Fab 25 originally was owned by Cypress Semiconductor. And then back in 2017, Cypress decided to keep Fab 25 and spin off the fab in Minnesota that SkyWater ultimately took ownership of. And so there's a history of these two facilities. And there's a common technology that runs in both facilities. It's a 130 nanometer programmable system on a chip, mixed signal ASIC type foundational semiconductor technology that we will certainly leverage between the two facilities. But they're also very complementary in that Fab 25 is a large scale, typical high volume facility, 40,000 wafers a month. The facility in Minnesota is more geared towards development, early stage production. So that combination will really give us a capability that will not only allow us to grow and scale our what we call ATS business, that's Advanced Technology Services, that's our monetized R&D capability, but also have a pathway for growing and scaling those customers that today are innovating with us. When those products hit the market, we now have a path to really ramp and scale while keeping customers like Infineon happy and Infineon's desire to have a domestic source for things like automotive and industrial applications can now be fulfilled while they still want to pivot to more of a fabless foundry model for some of their mission critical capabilities. Like for them, 300 millimeter GaN is a focus. Ultra thin processing for power semiconductors is a focus. Again, both on 300 millimeter. Having a foundry partner like SkyWater keeps them in the U.S., but also allows them to leverage the foundry model.
So we kind of jumped into the big announcement here. Why don't you give a little description for those that are not familiar with what SkyWater is, kind of the technology focus area, and just kind of the general overview of the company.
Yeah, great question. I appreciate the opportunity. SkyWater was created in 2017, back when the idea of doing a semiconductor foundry in the U.S. was kind of seen as a wild idea.
Yeah.
A lot of people were, focused on doing semiconductor, foundries outside the U.S., in fact. And one of the things that I had noticed was this lack of innovation on 200 millimeter. A lot of the industry had moved to 300 millimeter, and it had become very transactional. The smartphone was really taking off, and a lot of the innovation was actually happening on the design side or at the extreme nodes. Of course, that was TSMC, and those efforts continue. But innovation around the rest of the platforms was really lacking. And so the idea of SkyWater was really to create what we call a technology foundry. So a foundry that didn't just make volume products, but also had the ability to innovate with our customers and create what we call a virtual IDM-like experience, where even if you didn't own the fab, you had the ability while you were creating your product to co-optimize the process at SkyWater, so you get a more customized solution, allowing the process to be optimized as you were creating, the product, and do that in a very synergistic way.
And I think it's important to understand when you say IDM versus what you guys are, which is pure play, that means that you can take in designs from anyone. It's not a vertically integrated kind of company like an IDM would be. So
yeah,
major difference, right?
Yeah, and that was, that's part of the challenge too. So Cypress, who owned the fab, ran it as an IDM, so it was a captive manufacturing facility, had a small foundry operation that today we call ATS. So that was one of the things that made the acquisition attractive. But what really had happened was the industry, had moved to the point where doing innovation was happening primarily in labs, and then you had to go find some volume manufacturing partner, and that just reduced the time window that you had, because now you had to move it to another fab, you had to requalify, and it just took way too much time. So the idea of us was taking a fab that knew how to run volume manufacturing and build in a R&D capability so that now you were developing in a high volume manufacturing environment. And what that allowed us to do is not only bring a very rich tool set, because the fab in Minnesota was already doing 90 nanometer, which for 200 millimeter was, advanced, certainly advanced. 65 was kind of the limit for 200 millimeter, and then the industry shifted to 300. So we had an advanced 200 millimeter fab that was running volume production, but also had a capability, a foundational capability to do R&D. And so that allowed us to tap into certainly the DoD market. There was a lot of pent-up demand. If you recall, Global Foundries had just acquired IBM's microelectronics business. IBM had been a primary supplier to the defense industrial base, and so we came into the scene about the time that dynamic, of course. Global Foundries, owned by, at the time, was not a public company, was owned 100% by the government of Abu Dhabi. And so having a pure play, but also 100% U.S. investor-owned capability allowed us to capture the attention of the DoD, and that brought in some programs that really kind of got SkyWater on the map and allowed us to demonstrate this ability to do development in high-volume manufacturing environment.
Yeah, and it's an interesting band in which you guys kind of sit, right? You have those foundries that get a lot of public attention, let's call it, because of their node scaling and things of that nature. I like to refer to those as people that are easily seduced by technology, or technology seduction, right? They want the latest and greatest. Kind of like
exactly right.
when someone goes and hears that there's a new iPhone, right? You don't know why you're buying it, but it's new. So there's a line all the way around the building. But you break open that iPhone, and what are you using? State of the practice stuff, that secondary band,
Absolutely.
right?
The foundational semiconductors, as we call them.
100%. And with that foundational piece, it's also been reflected by the Department of Commerce when they came out with the results of their RFI study, one of the precursors to chips. It really highlighted that domestically, the biggest concern we have is state of the practice.
Yeah, it's the stuff that we all take for granted, right? It's like when you start your car, you expect all of it to work, but most of that technology is an extreme node. It's stuff that is made in 200 millimeter fabs on 130 nanometer, 90 nanometer technologies, and it's the stuff that not only drives the safety in an automotive, application, but also creates all the visual experiences, all the kind of multimedia entertainment value that we now expect from our cars, as well as getting us from point A to point B. A lot of it is also going into EV and hybrid vehicles in terms of controlling how you consume energy and how energy gets converted, from one form to another to extend the life and the usability of a car. So all these things really require foundational silicon. That's why both us and the U.S. government has started referring to it as foundational, because it really is that essential ingredient that makes the extreme node, the AI chips, all that doesn't work if you don't have the foundational semiconductors. And we think that's one of the things where SkyWater offers a unique solution set. We're not only innovating at 200 millimeter, but we're bringing that capacity, that scale to the U.S. as a committed supplier to the U.S. domestic market. And so Fab 25 is a good example of that. Us doing advanced packaging in Florida, bringing technology that currently is only available in Asia to the U.S. market, is all about creating this foundational capability so that for those companies that want to have domestic sourcing, we can provide kind of, again, an end-to-end capability of virtual IDM-like capability, not just front-end wafer fabrication, but all the way through assembly test.
So let's kind of break it up a little bit here. We have your Minnesota site and your newly announced Texas site, and we talked about pure play, and that's the fabrication space. And you have your Florida site that's doing the packaging. From a fabrication perspective, what is the type of technologies that you can find inside of SkyWater?
Yeah, great question. So in front-end manufacturing, we primarily do 130 and 90 nanometer. 90 nanometer is where we're developing a lot of our new capabilities. We have a strategic RAD-Hard platform called RH90 that is in the process of being developed. That was being done in partnership with the Department of Defense. Technology, we've not only are moving from traditionally it's 150 is where most of the applications are, so we're moving that to 90, but we're also putting in a copper back end and some enhanced transistor performance using an SOI-based substrate. So it's a fully depleted SOI platform that we are now building functionality, and there'll be different degrees of RAD tolerance up to strategic RAD-Hard. And then we also have what we call S90 low noise, which is used for readout ICs, thermal imaging platforms. We just announced that platform. It's called ThermaView this year, and it has a variety of applications that are coupled with our microbolometer technology. So this is an example of what we call CMOS Plus or CMOS Plus X, where we're bringing in a MEMS device and a CMOS device, and that's allowing us to create a lot of capabilities, again, for thermal imaging, whether it's on a defense application or an automotive application or a medical imaging application. This solution set is all really being built with our customers. And, ThermaView is a good example where we partner with two of the larger primes over the last 5 years to develop a platform that is now going into volume production. The platform was developed through our ATS model, which meant the primes were, basically giving us money to do the development, as opposed to a traditional foundry model where the manufacturer would go develop all that themselves and then try to recoup it when you bring it to market. So by generating the revenue along the way, we were able to not only create a solution that met their needs, but also bring in a broader set of customers, create a true platform, the one-to-many approach, to where now both of those customers are lead customers and getting the product into their applications. But now we have other customers that are doing designs and taking, we'll call it a more traditional foundry approach. And doing this, it's a way where customers can have influence over what the end state looks like, but also SkyWater doesn't have to do all the upfront investment. And having that kind of model is a way to, it kind of goes back to displacing these lab concepts. So in the old model, these same primes would have spent a lot of time in their own labs developing applications, but it would have been just for their applications. Each of the primes that we're dealing with sees benefit in us working with other primes because the application space is wider. They get the benefit of more silicon being run on these designs, gets to higher yields faster, and in the end, they get a faster time to market. So we think this type of model for, companies that don't require super high volumes but require a lot of process complexity is going to be very much value added. So, and then I'll bring in superconducting films technology. We're one of the leading companies in the world with that, working with, providers like D-Wave and medical devices. We do a lot with microfluidics and things, again, where we combine CMOS technology with MEMS technology.
So outside of just being a state of the practice or foundational, a fabrication capability, there's a lot of, I would call it boutique aspects that you bring to the table as well. It appears as though it's like a technologist haven, right? Where you
Yeah.
can say, look, maybe I can mix this MEMS device, like you said, with this CMOS device, and now I can have an application that is specific to my industry, opposed to going to 2, 3, 4 sites to try and kind of
Absolutely.
do this hodgepodge. It's all under one umbrella. Do I have it kind of right?
Yeah, we actually call it the innovator's edge
Okay.
for that reason, because what typically happens is we have some core capabilities, but a application that someone's looking to get to market, they can come in and not feel constrained by the fact that we only do CMOS or we only do MEMS, and now they have to figure out how to integrate it all together. Having advanced packaging even adds more capability there, because in many ways, most of the applications we do have some form of advanced packaging. You're taking a MEMS device, a CMOS device, an RF device, and putting them into a package.
And this is where the Florida site plays in, right?
That's exactly right. So that's where we refer to as a virtual IDM. So now in a vertically integrated IDM, everything's captive, and the only company that's getting value from it is the one who owns the assets. And the foundry model and the SkyWater approach, and that's why we call it technology as a service. You can either use one little component of what we offer, or you can put together an entire flow where you do the microbolometer, the readout IC, and the wafer level vacuum packaging, all within a turnkey operation at SkyWater. And that just creates not only more stickiness with us in terms of the wallet share we can go after with our customers, but also it reduces the time to value and reduces problem solving. When there's an issue, you're not dealing with 3 suppliers now, you're dealing with 1 supplier. And it gets their designs to market faster and allows us to get faster yields, or faster cycle times and better yields for them.
Yeah, what I've noticed is outside of the very recent announcement over in Texas, you've been able to get quite a bit of state support, both in Florida and it's Osceola County, I believe,
Yeah,
right?
Osceola County, exactly.
And then over here in Minnesota for your 2 sites. And I think that relationship, which appears to be extremely strong in both of the states for each of the different locations, has been a huge representation of not only the importance that you guys are bringing from a technology perspective, but the impact you're making in each of these different communities, right?
Oh, for sure. And it's the whole idea of public-private partnerships. And, we started doing this even before chips became, a thing. When we got engaged with Osceola County, they had built a facility that kind of had a false start. We came in, became the operator, and now in partnership with Osceola County, we've not only executed on some existing programs that they had kicked off before we got involved, but we've brought in another program, again, another DoD-funded program to stand up a wafer fan-out level packaging technology that, again, today exists only in Asia. Bring that to the U.S. It's on 300 millimeters, so this is our first move into 300 millimeter. And we're doing it in partnership where they're creating jobs. We have a STEM school co-located on campus.
And this is part of the NeoCity ecosystem, right?
Exactly. And so we actually have students that starting in 10th grade of high school can start interning at SkyWater, getting exposed to microelectronics. You think about workforce development. You've already have experience by the time you're going to college, and then you get injected into the college system. So by the time you graduate, you can literally have 6 years experience, working in semiconductor foundries. SkyWater is one. There's, Purdue has got a great program now where they bring students into their ecosystem, and we're seeing, I think, just this way to get people excited about semiconductors early in their career, so they're committed to making this the path they want to follow. As for us that have been in semiconductors, we're very passionate about it. But for a while, semiconductor manufacturing was not where people were putting, their efforts in terms of developing careers. And that's something we definitely have to turn around. And what we're doing in Florida is a great example of it.
Yeah, I'm not a marketing person, but I'm just thinking, you have these students coming in, you're giving them a pathway, right? And you could easily frame this as the sky in parentheses, water
Oh,
is
yeah.
the limit, right?
Oh,
So
yeah,
the
that's
sky's the
good.
limit here for these
That's
eager
absolutely
kids that
true.
are looking to engage in the such. Another big announcement recently, although it's been a few months, your guys' involvement in the CHIPS program.
Yes.
So talk a little bit about that. And I'm really interested in, there was a lot of boots on the ground that had to happen in order to not only get SkyWater, the awareness within those at the Commerce Department, but also the ability to help show that this is a foundational piece to the United States. Talk a little bit about how you kind of got from the T equals zero's time to announcement.
The whole CHIPS process was, think of it as two phases. One was the work leading up to the bill becoming law. And I think there was a lot of effort around, what is the right way, not only to spend the money, what's the right mechanism, the balance between creating capacity, making sure there was an innovation component, the carve out of the ME Commons piece for the DoD. So I think the execution of creating the bill, getting the law was just a tremendous achievement for the whole industry. And then once you got into the execution phase, Secretary Raimondo, former Secretary of Commerce, did a great job of bringing a team together of not only industry experts but financial experts, and really, I would say, moved at lightning speed for the government. From an industry perspective, we felt it was too slow, but from a government perspective, I'd never seen things move faster.
Having sit on both sides,
Yeah.
I know exactly what you mean. So
yeah, it was again, and part of the challenge is our industry is cyclical. So a lot of the demand statements that were being created when we were in the upturn, we were coming out of COVID, demand was high, and then of course we got into applications being submitted. And one of the things about SkyWater is we get a lot of investment from our customers in addition. So we refer to this as a CapEx-light model. So we don't just expect the customers to pay for the R&D, but if we need a new piece of equipment or even have to expand our facility, we would look to the customer to help co-invest in that. And so we were getting a lot of money from the government through other programs already. And so when we looked at what we needed through CHIPS, it was really focused around this idea of modernization, automation, and being able to take investment that we would likely do anyway in our fab and over, say a multi-year period, and be able to condense that into a shorter time frame. And part of the equipment and a lot of the investment that was already coming in, we felt could be complemented by having this CHIPS investment. So think of the DoD as buying a lot of equipment for us to enable certain programs. And then we use the CHIPS Act to modernize in terms of other, peripheral equipment, other, infrastructure inside the fab, clean room type infrastructure, and then just factory automation. And so with that combination, our program ended up being $127 million, of which we got $16 million from the federal government and 19, actually more from the state of Minnesota than we got from the federal government. So collectively $35 million. And that allowed us to take a 7-year investment program that we would do through just our normal annual investment and do it in a 5-year time frame. We're still waiting for the definitized agreement. Obviously, the change of administration has slowed things up, but we still feel very confident that it's not only something that will add value to SkyWater, but it doesn't, stretch us. Obviously, what we talked about at the onset, acquiring a new fab, we knew that was in the works, and so we didn't want to have to go invest a lot of money or bring in third-party investment to capitalize on chips. So we felt very strongly that by doing it within our normal spend levels, that would be not only a good way to go, but give us some elasticities for some of the other things we wanted to do.
And that being kind of the anchor site for a lot of SkyWater stuff, this investment in from the government, helps to influence, the Florida site with its packaging, influence what's going on in Austin. So it's a strategic move to make that the focal
Absolutely.
point.
And it's interesting. The fab was built by Control Data as a 6-inch fab back in the late 1980s. So Cypress came in the early early 1990s, and invested over $1 billion to get the facility to where it was when we took over in 2017. And then we've had over $300 million of investment from our partners to expand the facility, add in new equipment, add in the copper capability. And now with this additional 127 million, of which 35 coming from partners, you're really talking about another 30 years of life into this fab. And so it's a great example of how through a program like CHIPS and the Build Back Better regional challenge, the Florida facility got 52 million from that. These type of investments give longevity to fabs that already exist. And going back to the foundational semiconductors, these are the fabs that you need, that you don't have to spend time in greenfields and creating a brand new capability through a modest investment compared to the cost of some of these other fabs. You're not only extending the life, but you're bringing that capacity back to the U.S. in a way that I think 10 years from now we'll see has been absolutely critical. And you referred to it. We see the Florida facility and the Minnesota facility, and now with the Texas facility, all of them is kind of national assets, because we, as a foundry provider, pure play foundry provider, we're creating a foundry model and making this capacity available to companies that want to leverage the foundry model. And the DoD is in the process of moving from more of a captive model to where everybody has their own fabs to a foundry-like model. And we think SkyWater can be at the center of that.
Yeah, well, and the DoD is a perfect candidate for that, right? Because they have a high mix of technology requirements at extremely low volumes.
Exactly.
And so they're going to be looking for boutique solutions for many of their different systems.
Yeah.
But the upside to this is that though it may be boutique, the sustainment tail is extremely long. So once it gets integrated, I mean, you have a customer for 20, 50.
Oh, yeah.
In the case of the B-52, 100 plus years. I mean, it could be a very long tail that is there, right?
Yeah, and that's kind of the idea, is by having a foundry model for this community, they get the economies of scales that the commercial markets have enjoyed, because otherwise each prime is investing in their own lab fab. It's not really a fab because it's not running at scale. By developing in a high volume environment like we have, you're not only getting all the benefits that you get in terms of cycle times, improve yields, improve analytical capabilities that you typically have in a fab like that, but you're also getting the benefit of all these different programs synergizing off of each other. It's why TSMC, again, not only provides NVIDIA and Apple and AMD with super extreme node capabilities, but they all have a way to differentiate within that. And by collectively having all those companies invest and keeping up with the extreme nodes, they're all getting benefit, whereas each one of them would probably struggle to, and you can maybe look at Intel as an example, when you only have your own products, it's hard to justify that spend, which is one of the reasons they're not moving to the foundry model.
Oh, yeah, and it's a risky move. You've seen what happened with Pat Gelsinger. He didn't really get the warm reception from a lot of the board members on this pivot. So it's...
it takes time to make the reality. I mean, GF was created in 2009, and it's taken a good 15 years to get that model to where it's self-sustaining. And it's one of the things that when we created SkyWater, we were very focused on, which is how can we have a CapEx-light model? How can we push this investment on the product companies? Because they had gotten off in many ways for free, because they were saying, oh, go build your foundry, go build all the capacity, and then we promise you we'll use it when it's there. But all the risk was on the manufacturer. Mm-hmm. And I think in our case, partnering with the DoD allowed them, where they don't mind taking risks. They're looking for capability. They did investment that not only benefited them, but because of our model of being both DoD and commercial, we could take that investment and bridge it into the commercial
and it's non-dilutive, right?
Absolutely.
So that's a huge plus. It's and you hit on a key topic, and I know you and I were kind of riffing on this a little bit earlier, but ensuring that the consumers were held accountable for a lot of the fab capabilities and requiring them to kind of get connected at the hip with the fabs is a key piece. A piece that I feel is lacking from the CHIPS program. That requirement hopefully will be implemented here in the near future, because when you have demand, it will force supply.
And you're exactly right. One of the challenges with the CHIPS program was the manufacturers were going to take all the risk. You go build this fab, you can get the subsidies from the U.S. government, but on the other side, where was the commitment from the customers to say, we will use this product when you make the capacity available? And I think that's part of the dynamic that's going on now with the automotive companies. One of the things that we know Infineon feels very strongly about is their customers want their product made in the U.S. A lot of the customers in Fab 25 are from the automotive sector. And so, but it's one thing to say it, it's another thing to enforce it. Same with the DoD. The DoD should be required to buy chips in America, not outside the U.S., because it creates a vulnerability for us. And we need to have, a forcing function that says if we put the capacity in place, you will, procure it from that capacity source in the U.S.
Any ideas of that forcing function? I have a few of my own, but I'd love to hear yours. What do you think a good forcing function would be?
Yeah, well, I mean, there's different levers, but first and foremost is, Congress just enforcing the laws that we have, because in many cases, the laws exist. It's just there's been exemptions created along the way. Now, you also got to have the capability to make it available. If it didn't exist in the U.S. and you need it for a DoD solution, then you got to get it from somewhere. So I think part of it is making sure the capabilities exist, but then creating tentacles into the primes that says you will buy this stuff if it's available in the U.S. That's where you go for, your first source is the U.S. based source. And if you can't get it from the U.S., then maybe that's a different discussion. I think part of what I think would be great to come through, kind of this refresh of chips is where are the vulnerabilities in the supply chain? I know there's a Section 232 analysis going on right now, but we need to really look at where we have the Golden Dome, we have the F-47, we have these new capabilities we want to put in place. What's the bill of materials for the F-47? Where is all this stuff made? How do we make sure that the stuff that needs to be made in the U.S. is made in the U.S.? And then work.
I agree. And, the other piece that I would add to this is needs to be a little bit more pressure on those that are acquiring components. And what I mean by that is the real way to pressure them is financially.
Yeah. You just don't give them the money
or you give them money with the caveats that you build in the United States and we will give you X tax break, X amount of money, whatever it may be. And they will have the fiduciary duty to take this back to their board and say, look, if we don't buy U.S., even though it's going to cost a little bit more, we're going to get all of these incentives and we end up making out better. And when they're tied into your facility, all of a sudden, now you have a customer that has that sustainment tail we were describing.
Absolutely.
Right?
Yeah. And I think, again, one of the other forcing functions can be, the executive branch through an executive order or some kind of edict basically saying we will buy, these critical components from the U.S. and do it in a way where not only is the investment there, but you remove the roadblocks that create, that are created in industry for, putting the investment in place to make these capabilities available. Because it's one thing to say you'll make them. It's another thing to have the ability to make them. And I think, it goes back to there's core things we need to make. And on the other extreme, there's some very sophisticated things we need to make. And a lot of it comes in the advanced packaging side, right? There's a lot that can be done for counterfeit detection, where if we were to have to acquire a chip from outside, as long as it gets packaged in the U.S. and we put that final stamp of approval, remember the old Intel Inside? So part of our strategy is we want SkyWater Inside. So if SkyWater is the one who brings this technology together, does the final packaging assembly test, it's got a root of trust, a security level that gives confidence, whether it's a DoD application or a commercial application. And I think that AP can be a place, and certainly SkyWater sees this as an area where we expect to not just be a foundry provider, but a leading foundry provider. Having advanced capabilities in AP doesn't require the significant investment that advanced node does, like 2 nanometer, but it requires equal commitment from the customer side that if we put the capacity in place, it needs to be made. And that's part of our program in Florida, basically to bring in this fan out technology to serve the DoD community, but also make it available and have commercial customer support. And that's what we've been working on, is to create a solution set that not only meets the needs of the DIB, but also creates a solution set for the companies that do want to source in the U.S. And that's something where I think the U.S. can be a leader, is advanced packaging. And I know that that's certainly our strategy.
It's an absolute paradigm shift right now, where a lot of attention was on fabs, especially during the CHIPS initiative. The logical question is okay, after you manufacture it here, where are you going to package it?
Yeah, why do you want to send it back overseas?
Why is it going to Malaysia? Why is it going to Singapore? Why is it going to Taiwan? I mean, it creates that vulnerability. You talked about the security or the SkyWater inside kind of piece. That thought process has to be integrated into this if we're going to be building in America, buying in America, and distributing here in America. And it's gotten attention outside of just the Defense Department, your Florida site, which has been really interesting. In discussions with IMEC, I know that they've now created a pretty awesome partnership with you guys in the whole bridge facility NeoCity ecosystem. So I know that they're very excited about that. So and you're seeing a lot of pivots from others that are known as foundry capabilities, adding the packaging piece.
Oh yeah, I think it's really if you think about photonics and quantum, they all leverage advanced packaging to put the solutions together. And what's interesting is there's not just the movement to advanced packaging, but eventually the movement from wafers to panels. I just saw an article today that, basically by 2029, by the turn of the decade, you're going to start seeing the movement to panels. And that will be a big paradigm shift because, we're used to making things that are round. Now you got to make things that are square, and putting, die on panel is going to become kind of the mantra going forward. And that's part of our strategy with our fan out technology, is we're starting at 300 millimeter, but we believe there is a path to panel. And much like, think of Moore's law was all about shrinking transistors. Well, now we're just shrinking interconnect capabilities, creating more packing density, and instead of making each chip smaller and smaller, now we're going to be packaging things together in a tighter form factor.
Oh yeah, using the Z-axis, vertically integrating items.
Yeah.
It's funny because if you're a historian on semiconductor stuff, you look at what the Japanese investments were, like Panasonic, for example. They were into panel displays. Ultimately, it went into liquid crystals and stuff like that. Never migrated into this because it was ahead of its time.
Yeah,
right?
It was ahead, exactly.
And now, back to the future. We're coming back around, and it's like, wait, now we know how to stack things. Now we have an ability to shrink the interconnect density. Okay.
Yeah.
So how can we fit more stuff into here now, knowing that we have more real estate in all directions?
Yeah, that's exactly what it is. And it's just like transistors went three-dimensional. Now packaging's going three-dimensional. And you're also getting new substrates, the glass substrates. And then the other thing that's happening is new materials. So silicon carbide's now moving to 8-inch. And GaN, Infineon kind of leapfrogged the rest of the industry, and this was announced in 2023 when they skipped 8-inch and went right to 300 millimeter for GaN. And so now you're going to see these new materials that we've been hearing about for literally decades become commonplace in the industry, and that I think type of investment, it goes back to not just combining through advanced packaging silicon-based components, but now you got a silicon component, a GaN component, a SiC component, all going in the same package. So you got to be able to handle all that. And I think, these dynamics of new materials and how you, again, solve a lot of mechanical issues. A lot of front-end manufacturing is all solving chemical and physical type issues in terms of how you, pack more and more in the same piece of, real estate. Now it's all going to be how do we do that, plus take different components, put them together in packages, and packages that can not only work in the AI data center, but also can work out on the edge in these extreme environments. And, like We had a carbon nanotube program that we did with DARPA a couple of years ago that's now moved into ME Commons, but it's all about AI-based edge processors. So being able to have that same computational capability that we rely on the data center for today, imagine having that at the edge and being able to, in the fog of war, where you don't want to have to send something up to the cloud, you want to have that computational capability right there with the warfighter when they need it most. And I think these are the capabilities that, today even seem extreme, but by the end of the decade, this is going to be commonplace. The ability to process information at the source of attainment and then send it back up to the cloud for better analytics is going to be the norm, as opposed to now you have to almost send everything up to the cloud to get the computation back, and that just slows things down.
Well, and you're seeing all of these technologies accelerate at speeds that people never thought possible, right?
Yeah.
I mean, one of the things that I love to watch is the evolution of AI, right? You get these funky pictures that people tried to render, and it looks fine. Then all of a sudden, an arm's coming out of someone's head or something like that. And now it's almost to a point where you can't tell some of the differences between AI. And with microelectronics being a foundational technology which allows AI to happen, right?
Oh yeah.
It's something that is going to continue to push the boundaries of this. And that's just one vertical, right? You have all of these different sectors that it seems like it's just accelerating at light speed. So if you can't, create the density associated with electronics anymore, down to, past the laws of physics or, past the material constraints or whatever it may be, your next solution is the packaging area.
Oh yeah. Well, and think of quantum. So D-Wave, who's one of our customers we've been working with for many years, they recently demonstrate simulative, what they call quantum supremacy, which is a relative term, and I'll let them debate what's really what one is versus the other. But what they were able to do is, for a new material discovery, is look at every possible combination and do it in a much reduced time frame, not take years to do it. But and that was the real benefit. In a normal simulation, you only get to test so many components and so many vectors to get you to the end state, and you have to estimate the rest. They were able to look at every combination, and when you do that, you get a much more robust solution. And imagine now using quantum to solve problems that today we can't solve using even the best AI technology, and that will feed on itself. And that's where I think we are going to go through this exponential kind of evolution, kind of like when the PC was created back in the 80s, where just this massive wave of innovation, because we're going to literally use semiconductors to solve problems that's going to allow us to make better semiconductors, and that'll just feed into the rest of our world. And when I have a 21-year-old son, and I tell him, imagine what your life looks like when 40 years from now, when things that we can't even imagine today, and think back. I mean, how long is we've only had iPhones for the last 15 plus years.
Well, have you seen those new glasses they have where you can talk to? I think it's Meta that's in there.
Yeah.
Hey Meta, what is the origin of this plant, and it just tells you in real time.
Yeah, exactly.
I mean,
and again, everything will be autonomous. So now, when you're in your car, you won't be driving your car. It'll just be a transport mechanism. You'll be working just like when you're on an airplane.
Yeah.
Right. And
we're close.
I
put the self-driving on the way that I was driving to the Bay Area, or through the Bay Area, and I mean, it does the lane assist and everything. I'm able to get half an email in before it reminds me, like, hey, you can't do that.
Oh yeah.
But,
well, the funny part will be eventually we will be considered the risk items, having a human in the system, and so you'll have to probably pay money to go actually drive a car somewhere.
Well, and it's interesting that you say that, because I think one of the big inflection points in technology is going to be when we migrate from data centers that are using traditional CMOS technology into quantum computing, and that ability to accelerate all of the AI models, the machine learning and the such.
Absolutely.
It's going to just take us, like you said, to places that no one has ever thought of.
Yeah, and it's going to be something too where I think quantum computing, and then as you begin to position quantum computing, a lot of we're kind of moving from cellular networks to space-based, communication, things like Starlink,
yeah.
to where now, the biggest gateway has been getting all the data in one spot. That's a lot of what the big data companies have been doing, and now we have the processing power to turn that into AI applications. But quantum will just transform the speed at which computation can be done. And it's not just quantum computing, but it's quantum sensing, quantum communication, and all this is just going to exponentially change how fast information can move. And that's what's going to make autonomous vehicles a true reality. And because that's the biggest problem right now is we can't build enough data centers. There's not enough energy that exists to do everything we can envision doing. And so it'll take quantum to kind of leapfrog us into a new space to where, not only will the computation be faster, but the movement to photonics to where now we're, the data is coming in at the speed of light, not the speed of an electron, right?
Yeah.
And all this is just going to accelerate not only the ability to consume information, but turn it into actionable intelligence, which is, I refer to it as everything's just going to get much more prescriptive. So now instead of the phone doing generic things that we all can use, it's going to be very customized to each individual. And, I have this smart ring on that tells me everything about how I sleep and all that, but it's very customized to me. And now they've added an AI feature. It probably tells me more things than I want to know.
Yeah,
right?
yeah. Especially when you have a glass of wine, it tells you, hey, you know what, you're done for the night.
Yeah, you learn all the fun things you don't get to do if you want to sleep well.
Yeah, it's it's interesting. You kind of deviate a little bit on the quantum side, the quantum sensing one. The little I know about it, it is wild. You start thinking about how you're able to sense things without any kind of resonating, environment around it, and detect things with quantum, related applications.
Yep.
And then your brain just kind of starts going wild. Okay, well, where would they use that? And then all of a sudden, okay, I've identified maybe a couple applications. Why would they use that? And then you start thinking to yourself, this is a new world we're living in, right?
Yeah.
It's, just think, for example, a submarine, right?
Yep.
Submarines, you don't want to be detected, but you need to detect everything else, right?
That's right.
And all of a sudden, now you have a quantum capability that you're even more silent than the most silent, system that we have. It just starts to become, your brain can just start unraveling into all these different places.
Yeah.
And being at the edge here, helping to support companies like D-Wave, for example, in this quantum space, you're really, on the back end pushing a lot of these, technology enhancements for the future of mankind, right?
Yeah, I mean, that's really, if you think about quantum, it's going to be pushing qubits, right? So what does SkyWater do? We make qubits. And we have different companies that make qubits different ways. But just like we were pushing transistors, the goal is to get to 1 million qubits, right? People are in D-Waves like 7,500 qubits, and they're already doing amazing things. So when you think about, again, the industry, when the PC first came into existence, I remember being at AMD, getting all excited because we had a 40 megahertz transistor. And then like 5 years later, we were in gigahertz land. And so that's what I think you're going to see happen here. There's just going to be this wave of innovation. Now that AI is happening, people are building applications. It's coinciding with quantum becoming a reality. And that combination is really moving us out of the smartphone era into the AI era. And that's just going to not only drive more innovation, because it all feeds on itself, right? I mean, you look at a fab is run on silicon, right? All the automation, everything that we do in a fab relies on the technologies that we create. And I think, we're even with D-Wave today looking at how we can apply some of their quantum computing capabilities inside our fab. And these are going to, again, be things that feed off each other. And when you think about EV becoming a reality, and again, these new materials that, again, were always great ideas, but weren't scalable. It's all kind of coming together at a time when, I think the next 10 years, and everybody always says this, the next 10 years are going to be the best 10 years. But I think we're going to just see some amazing transformations. And you see the commercialization of space happening, right? Where things that, and that's something to think about as we begin to explore outside our kind of the Earth realm we're in today. Being able to make semiconductors in space will also become something that requires advanced packaging. You're not going to want to do all the front front-end processing, but you imagine being in space and you're on some mission and you've got to fabricate an IC because you need to solve a problem. You
Or you
can't
need to
say,
expand in a certain area,
yeah,
right?
yeah, our build, because you're building capabilities. You're going to be building, platforms on the moon and eventually Mars. These are all things that are going to create, whole host of new
When you
opportunities.
do your ribbon cutting on the moon, I do want a ticket for that one.
Yeah, yeah,
Okay.
that would be.
Uh, uh,
Well, I know, and imagine again people that are young looking at career paths. There's really no better place. Semiconductors are kind of like so foundational. It's like getting in the oil industry back in the 1900s, right? It just had tremendous upside. That's kind of how semiconductors, because if you like life sciences, semiconductors are involved. You like space, semiconductors involved. They're just literally everywhere. And I think it's just one of those things where if I have any concern about our ability to fulfill the destiny we have, is having the talent and the people that want to work in this space, because it's something where again you got to get excited. Semiconductor manufacturing is something that we will require a lot of talent and people that work on the very expensive tools that we buy, all the way up to the engineers that design the products that run on all these capabilities. But it's going to require a lot of new engineers that are passionate about really making a difference in this world.
Yeah, it's an interesting position you guys took because there was this common thought that if you own a fab, you got to do node scaling, right? TSMC very successful on this. Samsung has had success. Intel, time will tell with some of their
Right.
investments. Global Foundries decided no, not for us. We're going to stay kind of
Exactly.
in our position. So it almost appears as though SkyWater said, well, the hell with all of that stuff. Let's just skip all the node scaling and go to something that is
Exactly.
not in that same thing. Lesson learned from industry. A lot of investment, a lot of time, a lot of luck, and
Yeah.
it just will ultimately happen from the node scaling. Let's move over here to quantum. Do I kind of have the strategy?
It's exactly right. In fact, the whole idea was imagine you have a fab that was built many years ago running mature node technologies. And then what are you going to do with it? Well, what we decided is we're going to offer technology as a service. We're going to get our customers to essentially fund a host of new products, new capabilities that we brought into the fab. So the MEMS, the quantum, the microbolometers, the ROICs, these are all things that our customers partnered with us. So imagine now we're replacing all these legacy technologies with all these new technologies where we're the developer of. Our customers are just bringing new products to markets, not products that have been around for 10 years, but things that are just hitting the market. And we've got a bunch of new investment going in the fab that gives it another 30 years of life. And as you alluded to, these type of products, once you get designed into the systems, you got to make them for the next 20 years. So the idea of having this strategy for how you take an asset that you literally can buy for a fraction of what it costs to buy a new fab and create the longevity, the jobs. We more than doubled the amount of jobs that we had in Minnesota when we bought the facility, and we've created an R&D engine that now customers can rely on to come to and say, hey, we'll innovate with you, but we'll also provide you volume manufacturing. So we kind of look at Minnesota as our secure manufacturing R&D center. Texas is going to be our high volume manufacturing center. And then we have Florida as our advanced packaging center. And that combination, again, gives customers kind of everything they need to not only create new products, do it in a way where they can have confidence that their ideas not only that originate in the U.S., but will stay in the U.S. and have a complete value chain to get their products to market.
And you will have a contingency plan with the Texas site because now you have Minnesota as contingency. So
Yep.
if something was to happen, whether it be catastrophic, whether it be an oversubscription at the site, you have
Absolutely.
a place to go ahead and roll over, which a lot of facilities do not have that luxury.
Yeah, and that is actually one of the concerns that our customers actually had was, we are developing a lot of new technologies, which is great, but as these ramp, how are you going to have enough capacity? And even with our modernization program in Minnesota, we could run into a situation, especially in an industry upturn, where you never want to have to turn a customer away, right? And by having dual sourcing, it also reduces their risk. Like if you were to have an incident, like in Texas several years back, they had an unexpected ice storm, and all the fabs in Texas basically were shut down for a period of time. Well, we would have supply now in Minnesota where we could, who would ever thought you'd have an ice storm in Texas, not Minnesota, but having that capability, and I think it's a dynamic that will continue to unfold, is that there are a lot of 200 millimeter fabs in the U.S. that are owned by IDMs today. And this is kind of what we call the hybrid space. So these are guys that do mixed signal, like companies like TI and onsemi and LSI Logic. So there is a lot of 200 millimeter capacity that exists in the U.S., but it's not foundry capacity. And over time, I think you'll see companies like, what Infineon's doing, they're going to want to invest where they can differentiate, and some of that capacity can, continue to build out the foundry model. That I think you have to have a 200 millimeter foundry model if you're also going to have the extreme node, the more advanced stuff, because the advanced stuff doesn't work without the foundational semiconductors, which is one of the reasons why China has built 10 200 millimeter fabs over the last 10 years, because they see that requirement. If you don't have that piece, it's hard to make the rest of the system come together.
Well, I mean, there's stability there. There's a set of requirements that aren't going to change. You talked about it at the very beginning, right?
Yeah.
You get in your car and you just hit the start button, or you turn the key, and you expect all the electronics just to work.
Yeah.
And it's the expectation, right? So the future now for SkyWater, you guys have made a lot of massive announcements. This recent one here in closing on the Texas site, your Florida site, the CHIPS announcement. I guess what's next for SkyWater here?
Yeah, so we really we envision ourselves as being the semiconductor solution provider for foundational semiconductors in the U.S. We feel like that's a space that we can not only succeed in but win in, and be a foundational provider for foundational semiconductors. And then on the other side, we expect to be the leader in advanced packaging as we exit this decade. We think the technology, we partner with Deca Technology to bring in their fan-out technology. We believe that technology has the ability to scale and be very competitive with the best offerings from TSMC and Intel. This is a space where I think there's a lot of energy around the OEM community and the chip design community, the product community, to have a U.S. source, an alternative to TSMC. And so we expect to be known as a leader in semiconductor, not only front-end manufacturing for 200 millimeter, but also for advanced packaging here in the U.S. And then we also are very passionate about our secure manufacturing capability. So Intel gets a lot of attention around the secure enclave concept. Well, we have a secure manufacturing center that does the things that Intel's not paying attention to. Again, this is stuff they're focused on is 300 millimeter more advanced node. The other part of it is what we built here in Minnesota, and
you have a DoD approved accredited site.
Exactly.
The secure enclave is a concept.
It's a concept
that has not been backed by a DoD instruction. So though there's a lot of let's call it lipstick on the pig here. Let's the reality of this.
We have something that exists today.
Absolutely, and it has been vetted by two extremely important defense organizations. You have the DCSA and DMEA that combine to go ahead and get your accreditation. So a major difference. I just want to make sure that the people don't convolute the I guess topic du jour, which is secure enclave versus something that has been standing around for quite some time.
And that's where we believe that investment, and again, it's been investment we've made along with our partners, it creates a national asset that certainly we believe will not only be advantageous for the U.S. government and the DoD, but also other partners who want to take advantage of those capabilities. And that's, we've always been committed to being a commercially strong supplier who's willing to do work for the DoD. I think over many years, the DoD has had promises made, but not necessarily promises kept in terms of companies that were willing to continue to support them. And that's one thing SkyWater is very passionate about and we look at it as kind of the patriotic side of why we exist, is not just to bring semiconductor manufacturing back to the U.S., but make sure that for the capabilities we have, that we are a secure supplier for the DoD for the capabilities that they need for the long haul.
Having written a number of these checks, I know what you mean. There's a number of facilities that continue to hold the government hostage, saying, "Hey, our rates have now tripled. Unless you give us our money, we're going to walk." And they know that they have the dependency on systems. Hopefully there's a paradigm shift. There's a little bit more of that patriotism that comes around. Maybe we can tie this into when they have to pay their taxes.
Yeah, that's right.
They can understand, the impact that is happening when they do these negotiations. But
well, and I think too, this idea of moving to the fabless foundry model within the DIB is going to be something that will also unfold as this decade comes to a conclusion, where there really is going to be a foundry, like SkyWater, where the defense industrial base will be required to go to get their silicon fabricated. Not only because of, as you alluded to, the accreditations, but also just because of the economies of scale. You think about DOGE, you think about the government trying to be more efficient. We're kind of the poster child for that efficiency because, and a lot of foresight from some of the key partners we had at DoD saying, hey, we are going to build a RAD-Hard capability here that we'll invest in through the DoD, but then say the primes are going to now go get their silicon sourced out of there, as opposed to, again, having each prime build their own capability. I just, as a taxpayer, I'd much rather do it the SkyWater way than the current way, because it's just not efficient.
It aligns with one of the president's current initiatives, nuclear modernization.
Oh, for
and
sure.
so having a RAD-Hard aspect is going to be, a major piece to this. And then you look at the other side of that, right? That's the terrestrial applications. The other side of this is Golden Dome, another presidential initiative, and that looks at a different set of radiation requirements. So the RAD-Hard requirements are not going away anytime soon. It's integrated into a lot of the strategic decisions that are happening right now.
And it kind of goes back to the commercialization of space. There's different degrees of radiation hardness, right? And so you have strategic RAD-Hard, and then you have different aspects below that. And we feel like the whole commercialization of space is an area where we can be a very strong player in, because there's a lot of innovation required, even within thermal imaging. We have applications where the chip's the size of my thumb. We have other applications where each 200 millimeter wafer is a single chip. And that spectrum, being able to provide a solution set that meets the demands of all those customers that kind of have that breadth of requirements, is something that we think SkyWater is very uniquely positioned to do. A lot of other semiconductor foundries, they just don't want to go there.
And you're seeing a big push with these, kind of rapid launches that are happening. SpaceX, Blue Origin. We talked about Starlink at the beginning. I mean, there's a pivot away from just the government-specific investment. You're seeing it now on more of the commercial and civil side. Really taking charge on this and making sure that there is this evolution in space exploration, which will require microelectronics to enable all of the desires that all of these investors are making in this area.
Yeah. So drone technology is a good example too, because when you were only making 1,000 F-35s, that was one solution set. But when you're making 1 million drones, you have to be able to do things much more economically. And that's kind of when the industry went from the PC era to the smartphone. That's when the fabless foundry model kind of took off, because now you had to make billions of something, not millions of something. And I think that's going to happen as we move to drone-based technology. 100%. The requirements are going to be there, but you just got to make a lot more of them.
Well, and it's part of the overall strategic plan, right? Next Gen Air Dominance has 2 drones that are supporting, these other platforms, right? Yep. And they're even talking about a hybrid of an F-35 having a, no person in the cockpit.
Yeah, Nope,
right?
exactly.
So it is part of the technology evolution.
Yeah, and that's where AI and quantum, all the stuff we talked about, it all fits together.
Absolutely.
In terms of the master plan.
Well, Tom, thanks a bunch for joining me here on
absolutely.
the podcast, and I'm looking forward to the next set of big announcements coming out of SkyWater. So thank you.
Yeah, I've thoroughly enjoyed it. Thank you very much.